Thanks, Arne, for that interesting case study, and also Marcus. I think we heard a lot about some of the capabilities that we hopefully can expect from blockchain in the future, like notarization capability, transaction capability, be it data or be it digital assets. Of course, Big Brother capabilities, how much salt have they really poured on the streets. I would like to switch a little bit, so I'm still going to show industrial use cases, but it's more about how can blockchain and Web3 help with reaching our climate goals, reduce energy consumption. And if you switch back to the title slides, sorry, I'm giving you this talk from the perspective of a Berlin-based blockchain association where I'm the president. It's called Interplanetary Database. And I want to show you what some of our members, including Riddle&Code, where I'm working, are doing and how this can be, let's say, presented as an end-to-end case study where we start at securing data at a source and where in the end, hopefully, you see reduced amounts of electricity or energy being used. So it's about achieving carbon neutrality and what Web3 can do. Quick words about IPDB, a Berlin-based fee-free, so everybody can become a member for free. Blockchain association, we focus on trusted data handling and governance of blockchain, because in the end we can automate as much as we want. Governance and, let's say, human supervision or human setup of these cases in a proper way is still key. Our roots are in the BigchainDB ecosystem, one of the first blockchain/database projects here in Berlin. And when the BigchainDB founder team moved on in 2018-19 to set up what is today the Ocean Protocol, they donated the code and the brand name to the Interplanetary Database Foundation. So the community and the BigchainDB user community was taken over the project. We just recently, like 4-6 weeks ago, rebranded it as, on the next slide, after, let's say, 2 years of improving it. It's called Planet Mint now. You can guess where the planet comes from the IPDB. And the Mint hints that the governance is based on Tendermint and the Tendermint, let's say, governance toolbox. So it's a best of breed approach. It's an open source project. It's not a proprietary platform. And we launched it as part of the European Blockchain Services Infrastructure, let's say, upgrade project that is currently underway by the European Commission. There was a huge hearing about what is the industry expecting from a blockchain infrastructure in Europe. And as a result, there was a tender out in 2020 with, I think, 40 participants. I think 2 of the participants are in the room, so Holger and IOTA are one of the 5 projects that are currently working on this, and together with Dyn Foundation and an Italian ID provider called InfoCert, Riddle&Code. Dyn and Riddle&Code, RBDB members, are also working on that. And here it's about how can we scale in Europe, both in terms of throughput. The European Commission wants that basically every product that reaches the European borders can be registered and tracked, ID-based. So these are zillions of, let's say, object movements every year. So it's about scalability. It's about an energy efficient blockchain, of course. And that's why we pimped basically the old BigchainDB code base, launched Planet Mint, and this is the backbone of our proposition. And also, in order to mitigate the still happening or foreseeable energy consumption of such a blockchain approach, we also suggested the introduction of a green token, so that basically you could offset if you are a public service provider or an industrial company that uses that infrastructure, that you can offset the energy it consumes to really reach a carbon neutral balance, if you want. And to use tokens for that is also quite novel. So the Commission was interested because, of course, right now we are having a CO2 certificate market. We have the energy markets, for example, in Leipzig. We have lots of metrics and settlement mechanisms, but there is no real end-to-end settlement mechanism to tackle it. So we could, for example, use a token do that. So next slides. Let's now switch to, before we switch to the use cases, a bit of a history snapshot. So where's the DLT space moving? Right now we tend to use more the term Web3, even though by Web3 we mean a little bit more the applications sitting on top of it, and backend or blockchain is more moving as the standard backend infrastructure. But in the ICO wave between 2015 and 18, it was more about financing projects and companies. Energy Web Foundation is an example for a project that took on, let's say, the energy markets. Then we had a first wave of tokenization, basically in the financial space, basically tokenizing existing financial assets, and again, speculation, DeFi, etc. So a second wave, technically complex, yes, but not rocket science complex. And now we will add another wave of complexity, namely leveraging physical assets. So I think, Markus, what you said and the stories Arne was telling are going in that direction. We need to create the IDs for these physical objects. We need to make these data sets interoperable. We need to worry about governance, and then we can do something with it. And apart from transactioning them or giving credentials, we also need to associate the energy consumption data with it. And then we can tokenize both the assets and the data and rights, maybe. And then we can really use the incentive capabilities that blockchain is giving us. So next slide. And if we look at the sustainability goals that we have as a society, yes, we see pressure from the public arena, by also big swan events like the war right now. And then, so this is putting pressure on the regulators, and then bottom up, we see sector-specific regulation being extended, because of course so far safety was a concern, sometimes security, but now energy footprints, CO2 footprints are becoming a concern, a main concern of the regulators, so we can expect that the level of regulation is rising. But we have two problems, basically. Measuring sustainability efforts is difficult, and oftentimes we have quantitative goals, but we do not worry a lot yet about, how do we reach this qualitatively. And also we worry not a lot about the first mile, because still we are very high level in setting these goals, but how can we reach them? What is needed? And that's something that IPDB is worrying about, and that's also what our members are working on. So next slide. We will talk about the Oracle problem, which is maybe the biggest problem if it comes to trust. Once we have data inside a blockchain, it's protected cryptographically, so that's fine. But we know nothing about the provenance of the data and the trustworthiness of the data set. So the fact that it is on a blockchain is not helping us. We all saw it with the US presidential election, how difficult it is sometimes to determine whether a real-world oracle is true or false. So that's the main problem we see, especially for critical infrastructure, and that's why machine identity or object identity will be becoming terribly difficult. We all know that there are lots of identity providers for human identities on blockchains and standardization, etc. But we will mostly work with human and machine networks. And then again, of course, you have also corporations, the trust centers like Markus. Also, so typically there's a triangle: human identities, object and machine identities, and then there are corporate identities, and that's what we have to worry about. So we need trustworthy real-world oracles. Next slide. So now we take a look at the projects of some of our members. So we all consume on average 1 kilogram of steel, metals and plastic per day if we look at global consumption. Next slide. Industrial materials and their producers account for 10% of global carbon emissions. Next slide. If you look at steel, for example, or metals and how they are produced, so on top you see what we have today: traditional production, method. So the metal is mined somewhere and then it's extracted and melted and all these things. Now this production is about to change, so we have different production methods. So for example, the electric arc route, which you see here in the second row, and then more and more scrap metal, so recycled metal, is added to metals production. But only if we have a high degree of scrap metal, recycled metal, the best and most efficient production methods. It still uses a lot of energy, and only if the energy that is used for metal production or metal recycling is coming from green energies, only then we will hit a carbon neutral production process for metals. And the industries want to reach carbon neutrality by 2050, so that's not a long time for a conservative industry. And you see how significant the energy gains are. And that's, for example, where one of our members is active. It's a company called S17, a startup, next slide, from Austria. And I think the statement is fascinating because no company can be sustainable alone. No carbonization can happen without digitization of the data underlying these processes. No industrial digitalization can happen without sharing the data, and that's then where the trust problem kicks in. So no shared data can happen without decentralization and a sufficient layer of trust, because if in the end the BMW or Daimler CFO will have to pay huge fines because the CO2 footprint of their fleets is negative, then they will start to dig deep. Where is this data coming from? Is it trustworthy? What is the data accuracy that is coming from our suppliers? Because the CFO of BMW will not only be held responsible for the CO2 footprint of the materials the car was produced from, but also for the fuel consumption and the electricity charging consumption over lifetime of the vehicle. So they have to do lots of mathematical calculations, which are almost close to reading a crystal ball. So that means they need very accurate data to aggregate data bottom up in a reliable way. And I think this logical breakdown here is quite convincing if you think about it. That's why I have it here. Next slide. So here you see an industrial breakdown. You know, where are the carbon emissions happening across different industries, and where are the raw materials used in different industries. Of course, you will get the slide, so you can read this up. Next slide. And the S17 approach is, I think, something that especially new blockchain technology service providers, so Holger, pay attention. That's the approach they need to basically take. So come to us for the tool. We provide a certain blockchain capability. And then if you have a proper token dynamics, in the end, you will stay for the network. And then we have these, let's say, positive effects, hopefully. So what S17 is doing today, they are digitizing material certificates of quality and conformity, something that is legally required. You can't trade steel today or aluminum or plastics for the aviation or car industry without a certificate. So if you go to Boeing or Airbus, they have really luggages or cupboards full of documents, some printed PDFs or printed paper, because an airplane has a life cycle of 30 years approximately, and they need to know the material provenance of every bolt they are using. And just to take this process, which is quite cumbersome today, and basically base it on using digital twins, is a huge efficiency gain for big aggregators like Boeing, like Daimler, and all the suppliers downstream, basically. But today, once this data container is established, then of course you can add additional data points such as CO2 carbon emissions. You could use the full functionality of a wallet to also settle against these data sets, and that's how S17 is treating their business. Next slide. So that's a little bit how it works in detail. I think we will just skip over the slide again, read it up. But basically, they are not selling blockchain technology. They sell improved business efficiency for large-scale industries. They are helping to automate the quality assurance, which will serve as the bottom line for incoming regulation. And then they can proceed and also process sustainability data. So that's a little bit how the process flow looks like between an OEM and the raw material producer, and all of this has blockchain in the background, but they don't need to mention the word blockchain a single time in their sales process. So that's interesting. So what does it mean? Basically, we have lots of legally required audit trails, and so far they are partly digital, partly still analog, and using DLT here for efficiency gains is creating a perfect Trojan horse situation, and once this is done, then you can basically build on top of it. And in the materials industry, the legally required process for notarization of tons of certificates and data was providing a perfect entry point here. So next slide. Now we switch to Riddle&Code, another key member of IPDB. Just taking a tweet from our founder. Riddle&Code has built banking-grade solutions for digital asset management, including hardware wallets, but we don't use these wallets to store assets typically. We use it as access control devices. So entitled traders use their wallet to log into the system, and then you have basically a policy layer saying 3 out of 5 entitled managers need to okay a transaction if it's above a certain threshold. And with these kinds of key organization or signature orchestration processes, you can basically manage every access control mechanism or co-signature mechanism you can ever think of in industrial projects. And because we have launched this digital asset management solution in Switzerland, basically we have the whole audit trail requirements of the Swiss financial landscape in our backend. And that's also important if we talk about critical infrastructure, because in the end, it's not only about certifying data somewhere, you also need to have compliant processes to manage those data. So in the end, as Tom said in the tweet, we talk about cyber-physical systems. It's not just data management somewhere, and we learned about the Oracle problems. It's really cyber-physical, and that's need to be solved. But what are the building blocks? So number one, we have machine identity. And what do we do with machine identity? We use basically cryptographically optimized hardware, special crypto chips that solve the Oracle problem. You should have used a PDF. Now the proprietary font doesn't work, but let's keep it like that. So you'll get a properly designed PDF. And basically this crypto hardware turns machines into trusted data sources by signing all outgoing data. And this will be true for vehicles, it will be true for production machines, and also for some of the sensors. Number two is addressability. Once you have a crypto hardware out there and you add a bit of software and you give it an address in the Bitcoin address space, every object becomes addressable, and we can create a Siamese twin of a physical object on the blockchain. And Siamese twin means more than a digital twin, because basically the backend can ping the edge device. The edge device can confirm, yes, I'm still in the intended original state. If I'm a self-driving vehicle, my battery is still the original battery. The drive worthiness status, also in Poland, is correct. Or I'm a sensor at the outer perimeter of a nuclear power plant, and if Russia is not firing at me, I can still confirm I'm a sensor and I still work according to what is intended from me or expected from me. Then number three is we can automate and transact by adding a bit of software. Again, the wallet capabilities. I was talking about Riddle&Code being a service provider to the banking industry. So basically with this, we can turn every physical object into an autonomous economical agent in a marketplace. So every sneaker, every car can basically transact. And that's also why governance is so important, because in the end, they will transact based on a rule of smart or a range of smart contracts. And somebody, of course, has to audit smart contracts and supervise this. Number four, we need to level the playing field in the end. And that means we need to use confidential computing or zero-knowledge proofs or different kind of techniques to become GDPR compliant and also to allow competitors to work together without having to disclose their proprietary business information. If you can basically turn what we know as know your customer, KYC checks for digital identities or from e-commerce into the industrial landscape, so that only a service provider needs to set a threshold. I'm a ride-sharing service and I only need to know, I don't know, where a scooter is parked or when a train is arriving. I don't need to know all your business secrets. then we will hopefully create this level playing field, because so far, if you work with automotive suppliers, BMW, etc., the things they protect until they die, basically, is the encryption matrix for the telematics unit. Not even their garage dealers get access to them. They can only read out a few data sets. So we need to be able to automate data transfer end-to-end and data accessibility end-to-end, even if the data is coming from a vehicle that has been produced by an OEM and that doesn't want to share it with competitors. Because if I'm a fleet operator, I might have both Daimlers and BMWs and Ferraris in my fleet, and I need to get data out of all of them without having to be forced to sit with the CTO and negotiate it out of them, which will never happen. So how does it work in the end? We use different hardware form factors because you have certified chipsets in the energy sector, in the automotive sector. They are different, so they have to serve different purposes. Just think of one device. Next slide. That's something we use in the energy sector. We call it Trusted Gateway. And if we talk about production machines, it would then be a hardware machine wallet. And this ensures the notarization of, for example, data provenance, the energy consumption of a vehicle or device, and the type of energy according to the taxonomy that is just released, notarizing the CO2 footprint, and then potentially tokenizing everything if there's a demand for that information. And the ultimate ambition is, of course, to differentiate, if we talk about critical infrastructure, to talk about trusted data aggregation. That means notary-proof end-to-end data records, secure end-to-end handling of data, the possibility to tokenize data, and this will allow us to couple sectors like mobility with energy, like industry with energy, like products with recycling, etc., etc. So, one example, Riddle&Code teamed up, previous slide again, with Austria's largest utility company, which is now a lot in the news because they had problems with speculation at energy markets and were hit hard. So one of the companies that are currently partially saved by the state, but they became a joint venture partner after 3 years. So together, last year we set up Riddle&Code Energy Solutions, a 50-50 joint venture. And what did we do at Riddle&Code? We tokenized Austria's largest solar park and made these tokenized assets available to, next slide, end-to-end customers. So you see huge advertising campaigns from last summer. In Vienna, there's no word of blockchain here. Customers can buy into sun packages, so 250 euros basically, so you become the owner, or if you want, the beneficiary of one solar panel in this huge park. And then people get, back one slide, sorry. People get kilowatt hour tokens, so they are investing in an asset. They're getting a security token basically here. And then they get a utility token in their app, meaning the output of this asset, depending on how many assets solar panels you own, you get kilowatt hour tokens in your mobile app, and then you can redeem these kilowatt hour tokens. So either you can reduce your invoice, which is quite handy if you invested last year, and now you do not have to pay in euros, but in kilowatt hours, your electricity invoice, or you can redeem it, for example, for public transport. And these tokens work a little bit like Lufthansa bonus miles, so in order to stay away from the financial regulation, it's structured like a club, so you can only redeem it with a limited number of participating companies. You can't trade it at an exchange, so there's no fiat exit here. So what does it mean basically? First of all, an outlook for this year. We talked about sector coupling. So together with green energy, we will notarize green energy at a source of production, the solar park, and we will then make it available to e-vehicle owners in Vienna so that they can get a certificate when they are charging, that they are charging green energy. Of course, it doesn't mean that the solar park is connected to every charging station in Vienna, so there is a mass balance going on internally, but this will show how also top-down the notarization of green energy can guarantee to end users that what they are doing is green compared to maybe a a more expensive charging process with brown energy. So next slide, what does it mean? Again, if we can reliably notarize green energy at a point of production, 2 minutes, then this means we are having another entry point for almost every industrial process, namely we can certify green energy. And if we take that, we can certify green energy and we can certify and store on blockchain material properties, then we have 2 essential building blocks for every industrial project or process out there. So we start basically with these projects at the beginning of many industrial processes, and this Trojan horse situation is hopefully helping a lot, because if we look at the landscape, I think you have to click a couple of times to make all the buttons here come up. So just to look at what is happening in the industrial arena right now. We talked about EPSI 2.0, this upgrade of EPSI. So this will worry mainly about activities like ID management for passports, for birth certificates, for car registration in the public sector, but it will also, with the use case of product passports, influence the industrial supply chains. Catena X, which is the automotive cluster of the Gaia X European project, worries about the automotive supply chain, but they do start, and that's also part of the formatting here, they do not start at a commodity level, they only start at a level of parts producers. So they worry about recalls as OEMs. So if there's a recall for a BMW and they don't know where are the screws coming from, then this recall will get quite expensive. So they want to blockchainify their supply chain to be able to retrieve the correct information at all times. But as we remember, most of the energy consumption of a vehicle is coming from the energy or CO2 footprint from raw materials. That's why if basically they just start to collect the information at the parts producer level, they start quite late. And that's why what S17 is doing with these certificate handling is quite important. It will be rolled out with BASF next month for all suppliers, so that also for incoming materials, the OEMs will have a correct, let's say, database. Next slide. So what do we need to do as a society, but also as an association like at IPDB? We need to assess, of course, the final impact of regulation like MiCA that is just adopted in the EU and will also cover utility tokens. We need to ensure in the future thorough tech and smart contract audits, which is very important. We will need to make use of tokens to drive the behavioral change at scale, and most importantly, of course, design appropriate governance models that ensure that we include humans and machines in a future efficient society. So that's it. Thank you.